Hello, my name is Andreas Stuber from ExpertFlow. This presentation is an introduction regarding contact center technologies. So let's see what happens to a phone call when it enters a contact center. So we have a caller here whose call is transiting through the public network and reaches at some point a gateway. A gateway is a point where the digital telephony line, TDM, or usually coming through an E1 or through a SIP trunk, is being converted to IP telephony format in the format of SIP or similar. This gateway is also required if you have inbound SIP or IP telephony phone trunk, which will then continue as an IP trunk inside of the contact center. Now, the interesting thing with IP telephony that is not possible with traditional telephony is if, let's say, you have a voice stream here from the phone to the voice gateway. The voice path, which requires a lot of bandwidth, does not necessarily need to go all the way to the IVR, as it would have to do in the case of traditional telephony, but it can remain here. And all the announcements will be played here at the voice gateway. So this means that the voice gateway communicates with the IVR in a very similar way as a web browser interacts with a web server. So instead of speaking HTML with each other, they speak VXML with each other, voice extended markup language. So the voice gateway here, voice gateway, plays a very similar role as a web browser. And because of this reason, a voice gateway is often also called a voice browser. So voice browser is more or less the similar thing as an internet browser. So instead of displaying images and text and things like that, such as an Internet Explorer, for example, a voice browser plays out text and announcements and similar things. So once your phone call reaches a voice gateway or a voice browser, the voice gateway will be able to do the same thing with the voice call as an internet browser would be able to do with an internet session. And the way how the voice gateway communicates with the IVR is very much the same thing as a voice gateway, as an Internet Explorer speaks with a web server. And actually, the IVR is also running on an Apache Tomcat web server, so it's actually nothing else than a web server. And the protocol, as you see, is very similar. Instead of having hypertext markup language, you have voice extended markup language. Now, based on the calling line ID, and based on maybe some information that the customer enters here, so we can play, for example, once the call reaches here, the IVR can ask the gateway to play a certain announcement, which could be, for example, welcome at ExpertFlow, please enter your account number. So the customer enters his account number, and this account number can then be used to make a back office integration, for example, to a CRM solution. So here you might have a database of some sort, where we will, for example, retrieve a customer profile. So this could, for example, be we make a query. We say, okay, do you know this calling line ID? And the CRM tells us back, okay, this is the customer profile. Now, once the IVR knows the customer profile, it can give differentiated treatments to that particular customer. So, for example, it could give that customer a possibility to access certain services, or it could give this called priority routing, higher or lower priority, or something like that. Now, usually, what you could do also at this point is to have something like phone banking. So, for example, you ask him to enter an account number. You can make a speaker authentication based on the sound of his voice. You can verify whether this is actually who he pretends to be. You can basically do anything that the same thing as a web server is doing. So instead of having e-banking over the web, you can have phone banking over the IVR, because from an architectural point of view, it's exactly the same thing as e-banking. Now, if at some point you require an agent, you can forward the phone call to an agent using skill-based routing. So you can say, for this particular call, and based on all the information that they have gathered during the IVR session, I want to transfer the call to a phone agent. So the voice call is now being transferred to an agent, and the phone will start to ring. At this point, the control over the phone is handed over to the agent's desktop. So this is the computer or the desktop of the agent. And at the same moment where this phone rings, you can display the customer profile in the CRM. So the phone rings, and the agent will see, while the phone rings, he will see on his desktop who is calling me. He will see the exact profile of the caller here. So let's assume that this is caller Blue here. He will see that this is Mr. Blue while the phone is ringing. He can then, using a CTI toolbar, he can select to pick up the phone call. So he has usually a toolbar here through which he can accept, reject, or transfer a phone call. So basically, he does not, the call center agent will no longer use physically his phone. He does not pick up a headset or something like that, or pick up the phone call using his phone, but he will do that on his computer. The voice channel will still go through the phone, and in case the whole computer here, the desktop of the agent, crashes, the phone could serve as a backup. So the agent can still pick up the call, transfer calls and everything using the phone, but usually he will then do that using his CRM. And obviously there's an integration between the CRM server here and the CRM client. Or this could be an ERP or a ticketing solution or whatever. CRM client. It's also possible that you have multiple databases here during this interaction with the IVR or during the interaction with the agent, depending on the exact case that this caller is calling for. So for example, if the caller is first making a complaint and afterwards he wants to register a new product, you might have different applications that are required for this, so the agent might switch between those different applications. The important thing is that you have here a CTI control here. And in here there are two very important differences how you can do that. Either the CTI controls are embedded within the CRM application, or the CRM is controlled from the CTI application. So you could either have a separate CTI application. So the CTI application in this case would control the CRM application here, or you can have a CTI toolbar for telephony control within the CRM application. So in this case, the CTI controls very much look like a gadget within the CRM application. And typically this integrated approach where the CTI toolbar is inside the Blue CRM application is more user-friendly, because the agent will, at the morning when he comes into the call center, will just log into the CRM application, and while he logs into the CRM application, will be automatically logged in to the contact center through the red CTI controls as well. Whereas if you have separate applications, you will first have to log into the CRM application and then to the CTI application. So in larger deployments, you would usually prefer to have an embedded toolbar, and in smaller deployments, or if you have to have something very cost-effective, you would have a separate CTI toolbar. So this basically showed you the most important concepts of a call flow. Gateways, voice gateways, working as basically a voice browser, back office integration with the CRM or ERP solution, and afterwards interaction, CTI interaction for screen pop-up. So CTI, as we understand it, is pop-up of a customer information once the phone rings. It's not the same thing as a soft phone. A soft phone would mean that you don't have a phone here, but that you have actually a phone, a soft phone embedded here on the computer, and that you would have the headset plugged into the computer, like this. So basically you only have a headset that you plug into the computer. I personally think that this is a little bit of a risky approach in a contact center environment because the agents are taking phone calls all day, and in case Windows freezes or Linux freezes or you have whatever kind of issue with this particular desktop, this station would be out and the agent would no longer be able to take calls. Whereas if you have two separate devices, a phone and a computer, this one can very well crash and the agent would still be able to pick up phone calls. So this would have be in some cases an advantage. So just to differentiate, this is a soft phone, and this here is a CTI control. That's not the same thing. And this here is also not what we label CTI. I mean, this is what we call back office integration. Okay. Now, regarding deployments, let's assume that you have multiple contact center sites. And here the whole idea of IP-based contact center becomes very interesting because if you have, let's assume that you have callers coming in from, say, France, and you want to route them to a hosted call center or agents in Morocco, for example. In this case, you can place the voice gateways in France, queue all the calls on the voice gateways in France, play all the announcements until an agent becomes free, and only once an agent becomes free will the calls be transferred over IP to the agent wherever that agent is located. So you will basically only start paying for this communication cost here once the agent is actually available, and you will not pay for the communication cost as long as the call stays on the voice gateway. And if you later on want to deploy the whole call center over multiple locations, you could just simply distribute voice gateways on multiple locations. Each location might have its own agents. And so this could, for example, be several countries. At this point here, you could then basically, let's say you have a call center in Morocco, you have another call center in Switzerland, you have another call center in Belgium, and for example. So all the calls originating in Morocco would terminate in Morocco, all calls originating in Switzerland would terminate in Switzerland, and all the calls originating in Morocco, for example, would terminate in Morocco. And all you would need on the local deployments would be a voice gateway plus phones. So you won't need any servers on those distributed locations. And all the back office integration here, the CTI integration and so on, you will do this only once in a central location, and on all the remote locations all you need is a voice gateway plus the phones. So it's very easy to deploy the same architecture over multiple locations. That's one of the major advantages of using IP telephony in a contact center, and also one reason why I think that IP-based contact centers are particularly suited for emerging markets where you typically have bandwidth restrictions. Okay, so let's have a look now what else a contact center can do. So assume you have not only phone calls, but you have maybe emails as well, or you have additional chat requests. So if an email comes in from a customer, this email can receive, in a similar way as a voice call does it, receive automated responses. So you receive an email, you can look up the customer profile in a CRM database or in a travel ticketing tool or something like that. If the customer entered, for example, a ticket ID in his email, you can search the text of this email, determine whether you know this ticket, and then send an automated response back to this particular email destination. Once that might be it, and you won't need any agent, or you can determine at some point that you do need a call center or a contact center agent, in which case you would forward that email to the agent, like this. The contact center agent would then see that email along, again, with customer profile, etc. So you can also do a CTI integration for this email, and you can have predefined responses. So for example, you would have typical text templates within the CRM, or sorry, within the email response systems. So you can basically insert typical responses, for example, an account statement, etc., etc. So for example, if the email server here, so this could also be a contact center or the email server. If these entities here determine that this particular email is from me, it could determine that one possible answer would be to send an email containing an account statement. So the agent can then just simply click here on account statement, and it will insert an account statement in that particular email, which means that emails can be dealt with much more rapidly than if they would have to be written manually, and if the information would have to be extracted manually from different systems, because we can do a back office integration here, and then the content would be inserted automatically into the email. No longer would you need to insert this information manually. So this is an example for email. Same takes place for web chat. So you can have this scenario for email, you can have it for web chat. You could have it for SMS. Usually what we require for SMS integration is that we need SMPP interface from the call center service here to the SMS center of a service provider. So if we have this type of interface, we can deploy SMS services that will be distributed with the same mechanism to a contact center agent. So it can basically interact with customers via voice, email, web chat, or SMS. Now, the advantage of doing this is, doing this is called media blending. The contact center will distribute not only phone calls or the phone medium, but it will distribute other media such as email, web chat, and SMS. Why is this an advantage? Let me just... If you have, let's say you are in a passport or entry at an airport, for example, and you might have different lanes, right, for your queue. And here is the agent here. Then you have another queue, and another queue, and so on. Now, if you would not be able to see into the other queues, let's assume that you have to go into one single queue, it might occur that in one particular queue, in this queue, there are only one or two people waiting, and afterwards there is no caller or no customer to be served in this one here. And at this point, the agent that sits here is idle. So if you have several isolated queues, or several isolated call centers, or several isolated branch offices, or several isolated media, so this can be media, it can be branches, it can be call centers, etc. So as soon as you only treat each branch, each media, each call center in an isolated way, you will have the situation at some point where the agent will not be busy. So he will be idle and he will not be serving other customers. And this will actually result in the overall waiting times for customers who are unlucky to be in one of those queues to go up. And there's a law called the law of Erlang, which says the more media or the more channels you pull together, the more your waiting time goes down. And it's inversely proportional to the number of agents. So the average speed of answer is inversely proportional to the number of agents and to the talk time. So what you want to do is you want to have as many agents pooled together as possible, and you want to keep the talk time as short as possible. Another way of illustrating this is, so this is the number of agents here, and this is the waiting time. Another way to illustrate this is, I guess you know hourglasses, for example. So you have an hourglass where you have 100 grams of sand up here. Okay. Now, if you have 100 grams of big, clunky sand, do you think this sand will go through the hourglass quicker or more rapidly than if you have an hourglass with very fine sand? Let's take the assumption you have 100 gram fine sand and 100 gram large chunked sand. So the right response is that in the case of the fine sand, it will flow through the hourglass much more smoothly than the clunky sand. And this is because the big chunks will actually obstruct themselves, and this here will flow through much more elegantly. It's a little bit similar concept as here. So basically, having smaller chunks of sand, i.e. smaller talk time, for the same amount of sand, i.e. for example 100 call minutes or 100 emails, etc. So if you're able to reduce the talk time, the waiting time will also go down. And it's not only the savings in the actual waiting time that will reduce the thing, but the fact that having reduced waiting time per interaction, so making the same sand, the same amount of sand into smaller pieces, will just flow through the contact center more smoothly. So this statistical effect will basically allow you, and that's very important, and that's the economic reason why a contact center is efficient. It will allow you to provide better service with the same number of agents or with less agents. And this kind of economic benefit is something that you will only be able to do if you're able to virtually group together different media, different branches, different contact centers. So you can actually demonstrate mathematically why a contact center will always beat, hands down, any interaction with customers that works in silos. And this can be calculated mathematically, and you can make cost calculations, and you can calculate how good of a service can you provide at which cost. And it's important for companies to define how much they want to invest in a good service. Having, for example, a response time of 20 seconds for 80% of the call will not cost the same thing as responding within 10 seconds for 90% of all calls. So these are the basic economics behind a contact center, preceded by a technical introduction. Thank you very much for your interest, and looking forward to see you in the next video from ExpertFlow.